It's getting higher.
Hi guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So here's an empirical formula / molecular formula problem. So in this problem we have vitamin C, which is a compound that's made up of carbon, hydrogen, and oxygen. This problem tells you that a sample of 8 grams is analyzed and they end up with 3.27 grams of the carbon, 0.366 grams of the hydrogen, 4.36 grams of oxygen. So from here they want you to calculate what the empirical formula is. Well, the first step we need to figure out is the mass percentage of each element. And so let's start out with carbon so that I can show you how to do that. So for carbon, we have 3.27 grams of carbon divided by the total amount of the sample, which is 8 grams. Multiply that by 100 to get a percentage, and we end up with 40.9%. If you do the same exact calculation for hydrogen and oxygen, you end up with 4.58% for hydrogen, and you end up with 54.5% for oxygen. Wonderful. Okay, so since the empirical formula is the relative number of atoms, the easiest procedure is to imagine that the sample mass is 100 grams. So you get these percentages, right? But you just think about it in terms of this 8 grams being 100%. So in vitamin C, the mass of carbon is 40.9 grams. The mass of hydrogen is 4.58 grams. And the mass of oxygen is 54.5 grams. Really straightforward, right? So from here, you now know how to convert to moles, right? So 2 is convert to moles. So let's try again with the carbon. We have 40.9 grams of carbon. Divide that by the molar mass of carbon, which is 12.01 grams per mole. And this is a value you can get from your periodic table. And you end up with 3.41 moles. If you do the same thing for hydrogen and oxygen, you end up with 4.54 moles. The molar mass of hydrogen is approximately 1 gram per mole. And for oxygen, 3.41 moles. And the molar mass of oxygen is approximately 16 grams per mole. Okay, so now since we need whole atoms, we divide by the smallest value, basically in order to get the ratio of carbon to hydrogen to oxygen. So what's the lowest number of moles we have? 3.41, 4.54, 3.41. Obviously, it's 3.41. So now let's divide everything by that. 3.41, 3.41, 3.41, and what do we end up with? 1 to 1.33 to 1. So 1.33 is an awkward number, so we want to multiply it to the nearest whole number. So if we multiply each of these digits by 3, we end up with 3 to 4 to 3. Beautiful. Okay, so the empirical formula for vitamin C is C3H4O3. Yay. So you already did the first part. That was pretty straightforward, right? So now, in order to calculate the molecular formula, what you need to know is the molar mass of the whole vitamin C sample, which was found from mass spectrometry. So you're not expected to know this, don't worry. But now they tell you that the molar mass of vitamin C is 176.14 grams per mole. So since we know the empirical formula, we can figure out what the total mass of this empirical formula is. So the molar mass of C3H4O3 is 88.06 grams per mole. Again, that's something you get from the periodic table by finding the molar mass of carbon, 12 grams per mole, multiply that by 3, add that to the molar mass of hydrogen, the molar mass of oxygen. Just make sure you multiply it by the number of atoms you have. Okay, so you should get this value. So from here, in order to figure out what the molecular formula is, you divide the molar mass of vitamin C by the empirical formula in order to figure out what the ratio is, and this ends up being 2. So what's the molecular formula? We just have to multiply each of these quantities by 2, so we end up with C6H8O6. So now, as you can see, the ratio between the carbon, hydrogen, and oxygen is still 3 to 4 to 3, but from the molar mass we found out that we need double that of each element. So we did C6H8O6.
We just fucked it down.